Hello people, today we're going to learn guess. It starts with S and ends with S. If you are gifted, that is Surds. So today we're going to learn Surds. So I know after AP, after sequences and series and then quadratic equations, after all of those, right now I'm uploading Surds because I couldn't complete the portion last time. So I thought let me complete full 11th portion. So we have Surds, then next is logarithms, and then next one is sets and relations. So we will complete that slowly in our video. So first one we are going to learn Surds. So what is the Surds? So now let me just take my book so you know I don't teach anything wrong. And yeah, okay. Yeah, so if n is a positive integer, so n is something positive. N is a positive integer. Okay, this makes a lot of sense. And a is a rational number. A is a rational number. Okay, so a is a rational number, and a is always greater than 0. A is always greater than 0. Then and a is not any nth power. A is not any nth power. So when we get these characteristics, that is called a surd. That's called a surd. So there are actually many types of surds, like simple surd, compound surd, monomial surd, binomial surds, trinomial surds, the lot of them. And in surds there are many type of questions you can actually solve. So there are many ways how to solve some questions. So example, now root 2 plus root 8, how to add this? We can't add them directly and we can't make them root 10. We can't do this. So what we can do is, we can do root 2 plus 8, we can simplify it as 2 root 2. How is, in the sense is, root 8 is equal to root of 4 into 2. And then we can split the root for 4, root 4 into root 2. And we know that root 4 is 2. So 2 root 2. So 2 root 2 will come here, and let root 2 be some value x. If we can't directly add, so then it will become x plus 2x. What do we get? We get 3x. So what is 3x is equal to 3 into root 2. So 3 into root 2 is equal to 9 into 2, root 9 into 2, which is root 18. And this is a very fun type of problem we can solve. Okay, yeah. So these are not very hard questions, but there are some which can be conceptually damn challenging. So let's try to see which questions are damn challenging. Okay, before that let's learn simple surd. So now we will learn what's a simple surd. So now a simple surd is a type of surd which consists as single term. Example, root 2, cube root of 3, fourth root of 5, example. But how do we say cube root now, and we say this is fourth root. So the order of this one is 3. So this is the third order, and this is the fourth order. So these are main important things you need to do. This is third order, fourth order. So this is how we do surds. So this is basically surds. Next one is compound surd, I think, right? Yeah. So compound surd, compound surd, the surd which has two or which has some or difference as two or more surds. Yeah. So compound surd is exactly same as mixed surd. Compound is exactly same as mixed. Yeah. So now here compound surd or mixed surd. Compound surd or mixed surd is a type of surd in which it implies arithmetical operations except multiplication and division on two or more term. Okay, so example 2 plus 2 root 3 I wrote here. Next one is 4 plus 3 into fifth root of 3. This is not 35 root 3. So whenever they give this number bigger and the top they give the smallest number, you should understand that this is the nth root, or you can write this as 3 into 3 power 1 by 5. See, every root, like nth root of anything, can be always written as a power 1 by n. So nth root of a can be written as a power 1 by n. A power 1 by n. So these are main very important concepts. I'm not able to speak properly because I'm not well. Yeah. So anyways, leaving that. Now I think you understand compound surd. Next one is we are going to learn binomial surd. So binomial surd is when it implies two terms arithmetical operations except multiplication and division. So now 2 plus 2 root 3, the first example I gave on compound surds is a binomial surd. So now next one is similar and dissimilar surds. Similar and dissimilar surd. Before learning those two, I will explain one thing. So example 2 root 5. So 2 here is considered as the whole part, and this is called a radical. This is called a radical. So in a radical there are two components. One is this symbol as well as the number inside it. This symbol is called the radical sign. This symbol is called the radical sign. And this symbol is called the radicand. It's called the radicand. So this is called the radicand. So this is about this surd about here. So now I hope you understood this. Now coming to similar and dissimilar surds. Example 6 root 5, 3 root 5, 7 root 5. So 7 root 5 and 7th root of 5 is different. So you should have a comparison between them. See, 7 root 5 and the 7th root of 5. These both are not same. They have a difference. So 7 root 5 is this, and 7th root of 5 is this. Understood? So this is also one thing to remember. Yeah. So whenever the radical part is equal between some surds, so here root 5, root 5, root 5. So here these are called similar surds. Similar or like surds. Similar or like surds. But what if it's 6 root 6, 3 root 7, 7 root 5? So then they are called dissimilar surds or unlike surds. This is not unlike, this is unlike, okay? Unlike surds. So these are called dissimilar or unlike surds. Next one is I think this is basic common sense. Laws of radicals. So there are only three. So three laws is very important. Mth root of A into dot, dot is into nth root of A. Nth root of A plus nth root of A. Okay, if you don't understand the difference, I'll write pth root of A, pth root of A and qth root of A. Pth root of A and qth root of, pth root of A and pth root of B, sorry. Pth root of A and pth root of B is equal to pth root of A into B. This we can write. But what if it is minus here? Okay, let P equal to 2 for now. So example, minus A into root minus B. We can't write it as root AB. Understood? So here we have to take this as I root A into I root B. You learn this in complex numbers, so don't need to tension it now. You can learn this in complex numbers. I square is basically the square root is basically minus 1. I square is minus 1 and I is the square root of minus 1. So here we can't use this law. So what we do is we multiply the I terms. So when we multiply the I terms, it becomes I square. What is I square? Minus 1. And then root AB. So this is minus root AB, and minus root AB is not equal to root AB. These are not the same. So do not confuse in multiplying these two. Okay? They'll give now in YouTube some problems. They'll solve something and they'll say this is wrong, find the mistake. And whenever they use this property, you should remember pth root of A into pth root of B is equal to pth root of AB, where AB is always greater than 0, greater than or equal to 0, because if 0 into 0 is 0 itself, so greater than or equal to 0. Yes. Next one is the same thing for division also. Pth root of A by B is equal to pth root of A by pth root of B. Okay. Next one is qth root of pth root of B. Qth root of pth root of T. So now how to solve this is, see, A we can write it A power 1 by P power 1 by Q. You can write this as, and then A power 1 by PQ you can write, because 1 into 1 is 1 and P into Q is PQ. So this also we can write as PQ root A. PQ root of A. So Q root of P root of A is equal to P root of Q root of A, which is equal to PQ root of A. PQ root of A. Okay. So this is about surds. It's very fun and easy. Yeah. Yeah. So now we will learn how to do comparison of surds. Comparison of surds. So now how to do comparison of surds? See, example, 4th root of 7 is 4th root of 7 and 4th root of 8. Which one is greater? So now in normal conditions You know 7 is less than 8. So now fourth root on both sides. You get it. Right? Yes. So now I will take 5th root of 3, third root of 5 and 4th root of 6. Which one is better? So now take LCM on both sides. Take LCM on both sides. Multiply this one. Now what is 3 and 4 LCM? 3 and 4 LCM is 12. So I want to make this radical sign as 12th root. So then I have to multiply 4 here, and then to balance. Okay, if you don't understand that, I'll make you understand easier. Yeah. So which one? 3rd root, right? So now 5 power 1 by 3 and 6 power 1 by 4. Now I want to make the same denominator here. So now it will become 4 by 12, and this will become 6 power 3 by 12. Now 5 power 4 is 625 root 12, and then 6 cube is 216 root 12. So we know that 625 is greater under normal conditions. 625 root 12 is 12th root of 625 is greater than 12th root of 216. I hope you understood this question also. So that's it. Then rationalization. So now example 5 plus root 3, and denominator there is a 5 minus root 3. Now I want to make this denominator a rational number. So I have to multiply with the conjugate. And now you ask, what's the conjugate? Now see bro, a conjugate is if a plus root b is a irrational number or a surd, then a minus root b is conjugate of a plus b. So conjugate of a plus b is denoted by a plus b bar. A plus root b bar. A plus root b bar. Okay. So now, what is 5 minus root 3 bar? 5 minus root 3 bar is 5 plus root 3 bar. 5 plus root 3. 5 minus root 3 bar is 5 plus root 3. So I will multiply it on the both sides to make it an equivalent fraction. Then down I will get here minus, here plus. So a minus b into a plus b is what? A square minus b square. So 5 square minus root 3 square. Root 3 square is 3. 5 square is 25. So 25 minus 3. So denominator will come 22. And then 5 plus root 3 into 5 plus root 3. So 5 plus root 3 whole square. You will simplify and you will get your answer. Okay. But example 5 plus root 3 is have given. You are saved. What now? What if I give root 5 minus 6? What is the conjugate? Their conjugate root 5 minus 6 bar is, the conjugate is minus root 5 minus 6. How did I get this? Is because always the real part or the rational part should be in the front and the irrational part should be backwards. Should be backside. So then if I take the conjugate, it would equal minus root 6 minus root 5, which I can also write it as minus root 5 minus root 6. So both are equal? Yes. So this is about rationalization. Now I will give two search, try to find the comparison. Root 37 plus root 11, comma, root 41 plus root 7. Root 41 plus root 7. How to solve this sum is, see, first when you get plus here, you are saved. So now you have a plus. Here you will get one value. So what value you will get here when you solve? So you will get some decimal value. Get decimal value. Okay. So instead of finding and then comparing, this radicand multiplied with this radicand, and this radicand multiplied with this radicand. So it's 37 into 11 and 41 into 7. So 37 into 11 is 407 and 41 into 7 is 287. So which is greater? 407 is greater. So 37 plus root 37 plus root 11 is greater. So this is about surds. So we have to comparison of binomial surds. Now what if they give a minus instead of a plus? What if they give a minus? Example, root 8 minus root 3, then root 20 minus root 10. Okay, so how to solve this? Now I want this to become plus. Denominator, whatever value it be, I don't want. I want this to be plus. So how to do that is, see here. Yeah. So now, so now do rationalization. Multiply here. Do rationalization. Then you will get 5 by 8 plus root 3 you will get. And then this one, when you do rationalization, you will get 10 by what you will get? No, you won't get 5. You won't get 5. You will get 5 only, right? Okay, yeah, 5 only you will get. Sorry. This one you will get 10 by root 20 plus root 10. But now the numerator should be same. The denominator should not be same, and denominator, it should not be whatever value, it should be the conjugate value, and denominator should be same. But here it's not same. Here is 5, here is 10, but these both are multiples, so we can directly multiply 2 here. But whenever there is no multiple, you have to do LCM of these numerators, and then you should multiply the respective multiple to make the numerators equal. So now this will become 10 by 16 plus, so what? So 2 root 3. So 2 root 3 is 12. Root 12. No, this is root, right? So 2 into 4, yeah, 32 you will get. This will get 12 and 10 by root 20 plus root 10. Now multiply and check. 32 into root 2. So 32 into root 2, 32 into 12, what value you will get? 32 into 12, some value you will get, and 20 into 10 you will get some value. So which value is greater? Example, if this is greater, then this is greater. But if this is greater, then this is the answer. Okay? This is greater, okay? That's it. That's called comparison of surds. Next one, how to solve infinite terms. How to solve infinite terms. Yes. So now, example, root 3 root 3 root 3 root and so on. 3 root so on to infinite. Now, to solve this type, we should keep let root 3 root 3 root 3 root all the way to infinity be some value a. This same value should be a. So then root 3 into a into A is equal to A. How this? Because anyways it's going infinite. If we take one term from infinite, it will still be infinite itself. So this will be A. So now transpose this the other side. So 3A is equal to A square. A is equal to 3. Okay. So this is A is equal to 3. Understood? This is a Surds. Now example addition. Addition. So in addition, example root 2 plus root 2 plus root 2 plus everything is inside the root, okay, all the way to infinity. So how to solve this type of term? Keep again, let this term be A, okay. So then will become 2 plus root 2 plus A is equal to A. So then it will become 2 plus A is equal to A square. So we get A square minus A minus 2 is 0. You will solve this quadratic equation. You solve this quadratic equation, you will get 2 as your answer. Okay? You get 2 as your answer. You get one more value, and if it's negative, leave it. If it's negative, leave it. Understood? If it's negative, leave it. That should not be there. No negative. When you do like this, negative should not be there. Okay? You're adding roots. So when you add, you should get a positive number, not a negative number. So negative value, if you get, leave it. Okay? That's it. But now, is there any more topics? Let's wait for the drum roll. Oh, I think there's no drum roll here. Anyways. And yeah, that's it. So now you have saved. I'm saved. I don't have any concepts to learn. That's it in Surds. Yes. But solve the questions, practice your questions, and very importantly, learn, revise, practice, solve 1,000 questions you should solve to get your concept in grip. Okay, so that's it. I can tell you. All the best for preparation of JEE Mains, JEE Advanced, or whatever. For NEET also, I think this is there. Yes, so for NEET also, hi NEET students. If you're first time seeing this channel, hi, my name is Arnav Satya, and I teach math. Okay, I have uploaded many videos of quadratic equations and sequences and series, and there's some extra questions like depressed cubics and Ramanujan's sum solving. So if you want to watch more of my videos, you can go to my channel Mathjrwallah. Okay, so bye guys, this is it for today. I will be uploading more videos. Bye.